welcome to AFB UK NextGen online STEM events. You are highly welcome. This is our first event for the year 2021, and I am sure you've all enjoyed your Christmas holidays and you're so excited to be here. You are welcome to today's presentation on NASA space robots, the role of robots and astronauts working in space. My name is Dr. Orina Vivian Adegbotolu, and I am the AFBE UK NextGen Program Coordinator. It's so great and so delightful to have you beautiful and handsome young people here. I just want you to type into the chat where you're joining us from. Yes, I can see Aberdeen. Yes, I can see London. I can see Australia, Philippines. Amazing. Liverpool. Amazing. I know people are joining us as well from the US. Fantastic, fantastic. Thank you so much for joining us today. It's so amazing and wonderful to have you here. Just some housekeeping before we get started. Firstly, we would like you all to please mute your mics at all times except you're asked to do otherwise. Secondly, please type all your questions into the chat and my colleague Mo will pick them up and ask our guest speaker after she's giving her presentation. And thirdly, we'd like you all to sit relaxed and enjoy this very inspiring and educative presentation. Make sure you take lots of notes and please ask lots and lots of questions. Before we continue, I'm going to be introducing AFBE UK to you. AFBE UK is a registered nonprofit organization which was founded in London in 2007 with Dr. Nike Folayan as the chair. And the Scottish arm of AFBE is chaired by Dr. Ollie Folayan, who is also present here in the call. You're welcome, Dr. Ollie Folayan. We promote higher achievements in education and engineering, particularly amongst people of Black and minority ethnic backgrounds. The Scottish arm of the AFBE was inaugurated in the year 2011 and NextGen started in the year 2015. AFBE UK actually has different arms that run different specialized programs. The first one is NextGen, which is basically aimed at increasing the participation of young school children in STEM and preparing them for STEM careers in the future. Transition is aimed at increasing the number of university students who gain employment in engineering and STEM companies. The next arm of AFB that we've got is Real Projects. And the aim of Real Projects is to increase university students and STEM professionals' insights into real-life engineering and STEM projects going on in industry. The fourth arm of AFBE is mentoring, which is actually aimed at providing one-to-one professional career mentoring for university students and early career professionals. The fifth and not the least arm of AFBE is the leadership team, which is aimed at increasing employee excellence and promotion in industry. Now I'll go further to welcome our highly esteemed speaker all the way from the United States of America. I'm going to be introducing Sue Bonds. Sue, you're highly welcome to NextGen. It's such an honor to have you here today. So Sue studied mechanical engineering at University of Colorado, Boulder, Colorado. She is a robotics engineer at NASA, USA. She later became NASA Space Station Robotics Chief Engineer, and currently she is the NASA Orion FSW Test and Verification Lead. She had also worked in construction and then oil and gas industry before moving to aerospace. This great woman is also a mother and grandmother. She enjoys spending time with her family, motivating young people to believe in themselves and to explore space amongst other hobbies. You can see in the flyer a photo of Sue, which is a significant photograph that was taken when Sue participated in the NASA Apollo 5th anniversary, which took place on the 19th of July, 2019. So yeah, so I think that was the celebration of the landing mission. So Sue, you're highly welcome to NextGen. Let's give Sue a great welcome wherever you are. Just clap your hands and type into the chat, you're welcome. You're welcome, Sue. You can take over the podium now. Thank you.
Thank you very much for that nice introduction. I'm gonna work on now setting up my presentation. It's nice that we can meet virtually, and hopefully at some point in time I might be able to meet some of you in person and conduct a seminar maybe in Aberdeen. So today I would like to talk to you about the role of robots and astronauts working in space, and they work together. There's a lot of chores that the robots can do to help the astronauts. Now, as you know, what was just mentioned was that I got a Bachelor's of Science in Mechanical Engineering, and it was an emphasis with control systems like controlling valves and pumps and compressors and or servos, and servo actuators and electrical motors are in a robot. As indicated, I started working on control rooms. I designed, built, and checked out control room equipment. So some of you, especially in the Aberdeen area, might have family that works on oil rigs, and they have control rooms to help show the benefit, what the equipment is, how it's performing, and is it performing nominally or is it have an alarm? And then power plants have control rooms also. So that's what I started out with, and then I had an opportunity at a job fair to look at aerospace, and I ended up getting a job as a contractor early in my career and working on what I'm going to talk about today, the Shuttle Canada Arm 1. And I might end up using a technical term called the Shuttle Remote Manipulator. But then I moved to NASA and worked on displays like software like we're using today, and that was associated with robots. And then I moved myself up organizationally to become the robotics chief engineer for Space Station. And now, as indicated, I work on the Orion flight software test and verification. And the Orion capsule can hold between 2 to 6 people. We've had a prototype flight a couple years ago, and we're expecting to fly, hopefully, in November of this year. I think it might not be November, but we're working on having the first mission where it will spend up to 28 days in orbit and orbit the moon with a very, very large rocket. So now to move on, I guess I would like to know what you guys know about NASA. So this is an opportunity for you to answer questions.
What do you know about NASA?
I know what it stands for.
Okay, what does it stand for?
National Aeronautics and Space Administration.
Very good.
I also know that about NASA, the first ever time that was a big achievement for NASA was the moon landing.
That's great.
Yes, the moon landing was when I was a young child, and I never dreamed when I was a young child that I would end up working for NASA ultimately. And I thought I was going to be a school teacher, but some of my relatives' cousins graduated before me, and they were having difficulty finding a job. So then I just tried to look at other professions and came upon engineering, and that's what I started my course of study. But as you heard, I didn't start at NASA, and I ended up kind of by accident at NASA, which was wonderful. So it was founded in 1958, long time ago. And there are lots of different centers or places you can work in the United States at NASA. And one of them is in Langley, and it does aviation work. So it works on progressing how airplanes are able to achieve more automation and more safety. Then there's another center called Marshall Space Flight Center, and that works on rockets. And right now there's a big effort of making a significantly larger rocket so that it can take us to the moon and ultimately, hopefully, to Mars. Then there's the Kennedy Space Center that's in Florida. And so if you ever have the opportunity after COVID to travel, you might go to Walt Disney World in Florida, and you ultimately maybe take a side trip to the Kennedy Space Center, because that's where the launches of these rockets are and where the space shuttle formerly launched from. And Johnson Space Center is in Greater Houston, Texas in the United States. And that's where I work, and it works on the manned space flight. So I don't work on satellites or rovers that go to Mars. That's a different organization, so various areas have expertise or focus. Do you know anything about the European Space Agency? So this is another time to unmute your mics and volunteer what you might know about it.
I know that the ESA is the European Space Agency, and they're trying to work about the ISS. They're part of the ISS, or International Space Station. They're trying to send missions to Mars, I think.
Anyone else know of them? So yes, that's true. So it was founded in 1975, and its purpose is for the peaceful exploration of space. And it has over 22 member states of countries, and the British have an arm that are part of it, like the French, Italian, are some easy early countries to talk about but there's 22 different ones, like Denmark and Sweden are part of it. And it's focused on space adventures and, as the gentleman said, working on satellites, manned space, and ultimately, I think almost all space industries and countries would like to make more exploration achievements on Mars. And the European Space Agency provided hardware, and it's called Space Station Logistics Modules. So logistics modules means that you can bring hardware up and resupplies and like food and but if hardware breaks, that's what a logistics module brings. And there are three of them: the Leonardo, Raphael, and Donatelli. So like Teenage Mutant Ninja Turtles. And those were the names of those modules. Also, it's involved in providing the service module on the Orion capsule that I'm currently working on. So now I'm going to introduce you with a question of the next new thing for Scotland. Does anybody know about the Highlands Spaceport? So the Highlands Spaceport was just introduced and awarded, and it's going to be in Sutherland, Scotland. And the launch system, so the hardware to be able to accommodate the rocket to launch, is being built this year. And commercial companies are going to operate it. And a new startup company named Obex will launch a rocket called Prime. And it's going to have the advantage to take small satellites and go in a polar orbit. So go around the north, go around and make a different orbit. So the space shuttle and the Orion projects are not in a polar orbit. And these CubeSats that are about half a meter by a half a meter in volume will be some of the focus that this new Highlands Spaceport is going to do. So that'll be fun for you all that live in Scotland to follow that effort. So now I have another set of questions. Can you tell me what technologies or items have been a result of space? Like something that you probably don't drink a lot of, but like Tang was something that was a dried drink, like lemonades and Crystal Light and things like that. Tang was an orange juice drink that was developed because it would take a small amount of space, dehydrated, going to space, and then they would add water. So this is another opportunity for you guys to open your mic and answer the question.
Please, can you repeat the question?
So what things might have space helped with or founded in space? Because of space, things happened. So I guess another one I could offer is computers, your iPhone or your Samsung phone or another variety phone, your cellular phone. It wasn't
You got wireless headsets.
right. So some of these things were not truly founded because of space, but the miniaturization of computers, making them smaller and smaller. So to take things to space, the rocket only has certain amount of volume or space. And so in addition to that, a rocket requires a lot of fuel, the heavier and heavier it gets. So that's why you have this miniaturization. Anybody have any other ideas?
Astronaut ice cream is one of the available technologies.
Dehydrated food. Dehydrated food.
Freeze dried
Yes.
food.
You know that everything's like light in space, and you could lift anything.
Yes. But the rocket has to be able to have enough oomph to get it all to space.
Or you
So-
need
Hi, Sue. I'll just read out some of the chat boxes, some things people have said. Someone said GPS. Someone said space food. Someone said medical advances, memory foam, freeze-dried ice cream.
Oh, those are all wonderful. Yes. You guys are reminding me the foam, memory foam in their sleeping bags that they use. So here's what I put on my chart. Velcro, although Velcro wasn't truly discovered at NASA, it's used and commonly used about on EVA suits and to down. But something interesting about Velcro is like on space station, that's been human tended, or a man or woman has lived on space station as of this year for 20 years. So longer than you guys are alive. You were born after space station had people on it. And so that makes this talk kind of interesting for me because I'm a lot older. I'm probably your grandmother's age. And so the idea of people living in space is not uncommon to you. And also it's not uncommon to have computers that we're talking about, because we're talking today via a computer and advanced software to talk all around the world, which is wonderful. So computer chips became smaller and smaller. And so that was something we call avionics hardware. And it helps not only space, but helps aviation, helps you at home. And somebody was great and said something about GPS and the global positioning system for satellites. So there's a lot of satellites. In fact, there's satellites going to be launched again this week that are going to put more global things in orbit so people can have more technology. The GoPro is a camera, and that camera technology. So space is a very harsh environment, and you have to be able to withstand, the equipment has to be able to withstand, one, a vacuum, two, it has to be able to do large thermal swings. So very, very cold environment, and then all of a sudden it'll be a very, very hot environment. So that's what I meant. And the GoPro that you can buy at a store is actually going to be used on the Orion project, and they're going to see how well it is off the shelf ability versus adapting it significantly with space. Water purification is another thing, so that helps all of us on the ground being able to purify our water. And they actually on space station, all the condensation, so when it's a very humid day, some of that water is collected through the system, and then, not to gross you out, but when they pee, that water is also cleaned. And they do bring water up to space station in the logistics modules, but they also purify and recycle the water. As I talked about miniaturization, internet improvements, as we talked about the global positioning system, satellites, the mapping Earth. Now new cars or phones have a map application that can tell us how to go from our house to a new city, or avoid construction, or avoid traffic, and that's all significantly because of space. And then a thing on solar power. So you don't take a great big extension cord to space with a rocket. And so the batteries have to be recharged, and that's done through solar power. And then now we're even seeing self-driving cars. Tesla has other ones are coming out. And although Tesla is a commercial enterprise, some of the technology that was used in NASA and exploration has been adapted in that area. So now, to get on to the heart of my discussion, I was going to try to give us a definition of a robot. So there's all different types of robots, and I'm going to use the term robotics is a branch of technology that deals with the design, construction, operation, and the application of a robot. And that means sensing systems, vision systems, the control of them, meaning how to make them move from point A to point B. And then information processing means the status of it. Is it getting too hot? Is an electrical problem arising? Is there a hiccup with the software? So that's what a robot is. And I know all of you know about robots. Robots are much more common for you than they were for me. So let's, why don't you volunteer some of the robots that you know about? So this is another opportunity for you guys to open your mic or type in the chat window.
Reading robot. There are medical.
That was a good one.
Someone has typed into the chat box, Mars rover.
Yes.
So
Another. I'm sorry, I
Especially
didn't hear.
during this COVID time, there are medical robots.
Yes. They're robots that help the doctors do surgery. Like the a common name
do
to
they
Da
scan?
Vinci.
Do they scan things? Do they scan the symptom?
They're making a lot of progress on that, being able to do telemedicine. Not only did space help, but explore people in remote areas needed more telemedicine. In the last year with COVID, we've also seen quite a bit of evolution with being able to not require you to go to the doctor's office, but to have an interview by your doctor.
There are space robots who have cameras and they show the people on Earth what's happening on whichever planet they're on.
Yes, they give us insight, don't they? So that we didn't have to go there. The robots and rovers that went to Mars had cameras and were able to also like dig into the planet and do some geological testing to determine what the matter is, what kind of dirt, in quotations, that is.
And there's so in very few hotels there are assisted robots.
Yeah.
I'll just read some things from the chat. Someone said Chinese U2. Someone said solar-powered robots. Someone said restaurant robots. Robot vacuum cleaners, drone.
Yeah, drones too. Yes.
Yeah.
Okay, so I'll put what I put on the charts here, okay? Like the Roomba vacuum cleaner robot, lawnmowers that are automated where you don't require the person. But at some level, the old-fashioned lawnmower was a robot too, because it wasn't what you pushed it around, but you weren't using scissors yourself and cutting your grass. The Amazon has robots now that some of you volunteered there in this discussion that are stocking shelves. Then there's a big dog robot and Asimo robot that I'm going to show you 2 videos on. I'm not going to talk about those today, besides showing you the videos. And then there's the Segway robot, where you step on that platform with the wheels and move yourself about. You may have seen those in airports used by security or airport personnel moving about quickly. And or you can sometimes rent them and use them in as a touring capability to go up and down a city, like a downtown city, and go about faster than walking, but still not as fast as a car. So here we go with the big dog. So it's walking, and then it's trying to open the door. Now, so some of this work is fun, as you can see, but it's technical also, and there's ideas that it could help in, like rovers that work on oil platforms to inspect them, because that's a harsh environment, and or like in nuclear power plants or other places when there's been a disaster, and be able to open up the door and walk around and then provide that vision back, as someone said a few minutes ago, that they provide that vision. And here's the Osmo. That's pretty high technology to do all this. So now I'm going to talk to you about some of the space robots. So the Shuttle Canada Arm is about 15. So I'm going to do words for a minute. So this part will be slightly boring, but then I'm going to show you pictures. So the Canada Arm 1 was conceived in the 1970s. And then it was delivered in 1981 and went on the second space shuttle flight. And it's 15.2 meters long, and it's 6 degrees of freedom. And when I say that, that means it is like your arm that you have with a fixed shoulder, and it has those joints and can move about. Then on Space Station, which I'll focus on today, the Canadian Space Agency actually built these robots that I'm first talking about. And this is the work that I worked on as a NASA engineer, overseeing what the Canadians were building. And they built another arm that is commonly called Canadarm2, and it's 17.3 meters long. Its official name is Space Station Remote Manipulator System, and we make acronyms at NASA. It's like a foreign language, so we call SSRMS. And it helped build Space Station. So between Canadarm 1 and 2, it helped build all the piece parts that came up in the space shuttle to make what is now the space station. And then I've mentioned it helps on logistics and maintenance. The difference on this arm is it's 7 degrees of freedom and can take one end and walk end over end. So like taking your finger, your thumb and your forefinger and moving it about. Then Dexter is their Dexter system to help do like battery change out, jobs in place of the astronaut actually doing it. And it has two 3-meter arms, and then it has a rotary gripper device where it has parallel jaws. So it doesn't have a full hand, but it has 2 gripper fingers that also then has a rotary drive in it. And that's about 25 centimeters, and it's like a ham-fisted robot. So about the size, the end of that robotic arm is the size of a soccer ball. Then Boeing and NASA provided a mobile transporter that could move these robotic devices down the space station. It's like a little red wagon or a train in space. And then JAXA provides, the Japanese Space Agency, it provides a robotic system, and it's got one that's large, about 30 feet long, and then it has a small fine arm. So now back to the fun pictures. So this is the Canadarm1 that rode on the space shuttle, and it's approximately 15.2 meters long. So that's on the order of like 2 London buses put together. And as you see here, let me see if I can get the pointer working. Here's the shoulder system. So this is like the shoulder of your arm, then the elbow, and then down here is your wrist joints, which is the pitch, yaw, and roll. And then I may use the term end effector quite a bit today. I'm going to try to say end of arm, but that's the end of the arm that then grabs the payload to maneuver it. This is the actual photograph of that arm in space, in the camera here looking down at the astronaut. And I just want to give a perspective. This
It looks like it's upside down.
This is a shoulder here. And yeah, and it's extended, and the tip of it is looking down. And yeah, I guess space is relative. So yes, the Earth is up high there in this picture. And this is showing a comparison of an EVA astronaut. EVA means extravehicular activity, but outside. And he or she's in her suit, and they have to get all their air and life support. So this is a mini space vehicle, their suit. But they're working the task here, and then the robot arms helping show what's going on. And this is a space shuttle picture. So the space shuttle was built a long time ago in the 70s and flew in the 80s through 2011. The last flight was in 2011. So some of you weren't even born when the space shuttle retired. So this is a hardware display and controls. And this is, to go to space is hard, harsh environment. So this was how to pick the different joints, and this was the different modes the robot could operate in. But I think what you guys will find interesting is these 3 boxes here are the displays like what's on your phone, your cell phone. So they could show that the positions of the joint, but because there were 6 joints, they had to move this rotary switch to see that the shoulder joint was at 40 degrees, the elbow joint was at 60 degrees, and maybe over here the wrist pitch joint was at 20 degrees, and then they had to move this switch to see what the yaw and roll were. So it was crazy. And what happened is, so these switches were built like in the 70s, and then as things got older and older, it was hard to find the manufacturer of like this switch, I know specifically, quit making them. So we had to go out and find somebody else that was willing to make that switch again. These are the translation, meaning X, Y, and Z, in and out, or up and down. And then here is the rotation controller. So these hand controllers on
it doesn't say like X or Y on any of them.
what?
It doesn't say X or Y on any of them, but
No, but that's what translation means, is X, Y, and Z. So if you pushed in, depending on what your coordinate system was, that might be X, and Z might be up and down. So hand controllers were used to fly the space shuttle. They also were the same hand controllers were used to operate the shuttle Canada Arm 1, and then these similar types are used to operate the robots on space station, and also to fly like the Dragon that went to space station, the new capsule that was done by SpaceX. It has similar hand controllers. So this is the animation. So as I told you earlier, the Canadian Space Agency built these robotic systems, and this was something I found in their newspaper, Globe and Mail, on showing the illustration of the movement of the pitch joints. Now I'm going to show you how the arm yaws and rolls. So in this side view here is the rolling action. Some of these terms might be new to you if you haven't worked on airplanes or drones or followed space. Or robots. So these are some terms that are used commonly in robotics. So you have to grab something. You grab a payload, and to grab it, you use this. This fixture is on the payload or the hardware that the arms are going to grab. And I'm going to show you a little video that has the showing how it grabs with snare wires this pin, and then ultimately the cam provides the hard dock final resting so that you can then pick up the payload and maneuver it about. This grapple target's used for the camera system to help tell the operator how to position the end of the arm of the robot. And then if something were to happen and the robot couldn't let go, it had a hardware failure, they have these EVA drives so the astronaut could go outside and get his rotary drive and pull these bolts out and release this from the payload. So that's one of the technologies you have to worry about when you design things to go to space. Is one, you have to make it redundant or fail safe and or able to be maintained by you look into maintaining it by robots or by EVA astronauts. So this is the robotic arm going and grabbing that grapple fixture. So you see it has snare wires on the inside of the end effector or end of the arm, and it moves in a rotating way to grab that pin, and that pin has a knob at the end, so that's how it doesn't come completely off. And that shaft there on that pin is about 10.5 inches. Sorry, I didn't do the conversion to centimeters. So the Hubble Space Telescope might be something that you've seen a lot of images on. So early in my career, I actually, when I was still a contractor, did some analysis to determine how to take this very large payload here that weighed on the order of 24,000 pounds, and it was took up a lot of volume. Lost my cursor. There's my cursor. So the cargo bay here is 18 meters long, 18.3 meters long, and then it's 4.6 meters wide. And here's the robotic arm that is in its stowed position. And then it moves and maneuvers and grabs a grapple fixture that was here and to move it out. So I did analysis to determine that it wouldn't collide as you did the robotic maneuvers, and also determined that the loads weren't too high to backdrive the joints. And I had to do a lot of computer simulations. And I remember that I did 256 evaluations to be able to determine that it was safe to maneuver this out of the cargo bay. So here's a picture on orbit of the deploy mission. And here's the robotic arm holding on to that, what we saw in the cargo bay, the canister. So the grapple fixture's there. And here's some of those solar arrays to help charge the system. So you had to worry about, there wasn't electricity. Once you took it out of the cargo bay, there was not electricity to power the system. So you had to deploy these solar arrays, and you had to make sure that the arrays did not collide with the arm. And you also had to worry about the loads. And I'll tell you that the initial solar arrays were flimsy. And so one of the maintenance missions changed these because these bistems were not strong enough, and they actually warped and weren't providing enough power back to the system. So now I'm going to move on, and some of you might have different ideas, career objectives at this point in time, and some of you may be very artistic in your brain. And so I'm going to say that this illustration here was done as what we called an artistic rendition through graphical simulations of what the Canadarm 2, which is here, in the mobile base system, and then the mobile transporter look like. This was an early rendition of that, obviously very high resolution, but this was used on pamphlets, like to do public affairs and to communicate to John Q. public and or in technical world of what the Canadarm 2 was going to look like. So this was way before there was actually hardware cut and manufactured. So something, so the
Ooh,
robots,
is a spaceman on? Oh, is that a spaceman on there or a robot?
yeah, it's a spaceman, EVA astronaut on the end of the arm. And this is something that when the Space Shuttle arm was initially designed and tested, no one thought about putting the astronaut on the end of the arm. They only thought of this robot as maneuvering payloads about so you could deploy satellites or construct things. And early, I would say about 5 years into the Space Shuttle arm operations, someone came up with the idea of putting a workstation, a foot restraint on the end of the arm, and then have the astronaut stand on that foot restraint. And then you have an astronaut on the inside of, in this picture, this is Canadarm2, space station, move him about. So he can work at site A and do some like bolt tightening, and then he can go to site B where he needs to take the battery out and put in a new battery. So this has become something that wasn't initially thought of, but is standard operations. And in fact, this week there's going to be, or this next Wednesday, and then the Monday after that, I think that's February 1st, 2 astronauts are going to go outside and do tasks. And I bet you one of them will be on the end of the space station arm at some point in time. So this is that cooperation I talked about. Nowadays, the arms allowed for the astronauts to do more different tasks themselves, but also we were able to move large volumes and large mass. So this, where's my cursor? This here is called a logistics module, and it took up quite a bit of room in now the rockets. And so the astronaut, he can't maneuver that. He can only maneuver something the size of a telephone booth in front of him. I know I'm dating myself by telling you about a telephone booth, but something slightly taller than him, and but as wide as him. He can maneuver around. He can't maneuver things that are bigger than that. And you'd say, well, it's weightless in space, so surely you can do it. And part of the problem is if he maneuvers too fast, his space suit has design limitations. He can't put his arms up, way up high. He can only put his arms basically in this volume that my cursor's making. So you don't want him to have to move and jerk things around to cause damage to his suit. I'm going to say that these are the dots, the space dots, and this is used to use space vision to help maneuver this Canadarm close to this device. You need precision to be able to bring it close to it. So that's what we mean by cooperative tasks. So you see the robots moving the large item, but you see the astronaut here has some tools. Dexter is the special purpose manipulator. And Dexter means doing smaller tasks, fine motion tasks. But this is a huge robot to do that. It has 2 arms here that are essentially meters in length. They're 6 degrees of freedom like your arms, but they're 10 meters long. 3 meters long, 10 feet long. Our arms are not 10 feet long. And then down here is that ham-fisted robot I told you about that has the parallel jaw grippers and has a rotary drive in it. And it's about the size of a soccer ball. And this Dexter is located on the space lab. And then this space station arm is over here on the Columbus module. And you notice that was provided by the European Space Agency. That's their logo there. So here is that Canada Arm 2 here that is 17 meters long. And then here's that Dexter that I just told you about, all crinkled up in this photograph. And then this is the equipment it's getting ready to change out down here. So this is the flex hose coupler. So think of if some of you have flown on airplanes, the kitchen has some hardware in it and they move those carts in and out. So that's kind of the task that we're talking about, having the robot move those things in and out. Here is Dexter, and this is the computer animation that is on the international docking adapter here, and it's doing some tasks so that this EVA astronaut doesn't have to do it. So I'll tell you that things have changed so much since I first started. When I first started working aerospace, all this graphics was done in wire drawings, making lines. And that made it very complicated to see what the task is. And so the evolution of solid graphic models not only helps you guys play your video games, but also helps us in space. So see if you like some of that computer work. You can do that in various industries. You could do it in the gaming industry, or you could do computer simulations on space station or the next Orion project and others. So I told you earlier that the Japanese provided a module. So this is their Japanese experiment module. And they built about a 30-foot arm here. And they built, Toshiba company built this part of it. But down here at the end, this end effector or end of the arm, that was built by McDonald Detweiler in Canada. So see how international and cooperative we are? We have so many different countries helping each other out. And here is what space station looks like today in orbit. So these pieces all got put together, and now it's on the order of 3 soccer fields long. And here is, this is a zoomed out view, but that's the Canada Arm and Dexter on its mobile base system and on that little mobile transporter, Little Red Wagon. And that Little Red Wagon can go from this parking place down here, and then it can go to here. It can't go past here, which is called an alpha joint, because that rotates and we didn't make the railroad tracks go across. But to help identify some other hardware is, these are solar array panels that help charge batteries that are here. So there's actually a task where the robot can come down here, and then the robot deploys and Dexter end of it, and they change out the batteries here. I think, in fact, some of that task is going to happen this upcoming week. And then you see the Japanese experimental module here. And then some of these other things are antennas and booms on the systems. This is the next Robonaut. So the division that I work in at NASA is called Automation, Robotics, and Simulation. So people spent quite a few years, NASA's logo's here, and then this logo is General Motors, a car manufacturer in the world. And they work cooperatively to try to come up with a robot. Initially, it did not look like this, but over the years, it evolved. So this is like what Sue Burns calls the Darth Vader, but it has 2 stereo cameras here and does the vision system. And then when this is at 6 degrees of freedom on, and then you can see the hand. And so this hand mimics our hand. So some of you might have interest in biology and physiology. And so some of the engineers, I remember going into their lab and to ask some questions about things. And I saw them taking their finger and moving it up and down. And what they were doing was looking at how their finger moves, going from straight to down and how the joints move. So there's been significant progress since Dexter was built to have this robotic hand that looks like a human hand. So this is commonly referred to as a humanoid robot. What I find interesting was this wasn't necessarily designed to go to space, but to work at NASA and General Motors, like to help car manufacturers offload the worker and manufacturer in doing some repetitive tasks. And then they decided to move it to space station to get some more data. Here's an astronaut shaking hands. So kind of interesting with the robot here and him with his human hand and the robot hand.
Well,
So
it looks like they've made friends.
yes. And the Robonaut was designed to do various switches, and you can see picking up the cover of the switch and then closing the cover of the switch. And there's other knobs here and things like taking out connectors. So this was launched quickly and gathered a lot of data, and then it's come back to Earth. And then you can see other versions of this when you guys go to Google and YouTube and search on it. Have fun doing that. So here is what you guys have the opportunity that's just starting to be designed is the new space station to go around the moon, be a lunar area to hang out. And this is what's happened in the last month is the Canada Arm 3. So the Canadian Space Agency is going to build a robotic system and provide it here to the Gateway Project. So once again, this is an artistic rendering of what we think the engineering is going to be. Now I'm going to totally switch gears. Your British astronauts that have been in space. So in getting ready for today's talk, I was really surprised that this Dr. Helen Sharman was the first British person in space. I learned something. She worked on the Project Juno, and she launched on what was called the Soviet Union at the time, but on the Russian system, which you commonly know as Russia now, and went to the Mir space station. You know how she got there? She answered a radio advertisement that was asking people to submit their application to be a volunteer to go to space. And she won out over 13,000 people and got to go in 1989, before you guys were born. And the one I actually thought was the first British citizen to go to space is Michael Foale. Excuse me. And he actually became a NASA astronaut because he was British and had dual citizenship. So he applied to become an astronaut and got selected as NASA. And he went on multiple missions. He's now retired and working in education.
And he's upside down. Look.
Yeah, what you think of is upside down, but when you're in space,
No gravity in space.
Zero gravity means you can float anywhere.
Yeah,
that's why some astronauts
and also
float in space.
Also, you can lift heavy things because they're weightless.
yes. But he's in a harness system working on a treadmill. And you see, he has to be tethered with this shoulder system to stay on the treadmill. Otherwise, he'd float off. What I found interesting, or what I've known, so I worked with this gentleman. I never thought in my life that I would work with astronauts. But in robotics, you end up working with astronauts quite a bit. Anyway, he flew on space shuttles to the Mir Russian space station, and then he went to the International Space Station. What was also interesting is that he's worn both EVA suits. So the suits that you've seen in the pictures today are the US suits, which are more flexible and not rigid. And then the Russian suit is made out of hard volumetric materials. So you get into a hard suit that snaps together differently. So I found that an interesting trivia. And then the next one, you probably know. So I didn't list all the people that have gone to space, British people. There's at least 6. But I'm sorry. My next picture is the Mir. This is the Russian space station. So these are solar arrays here and radiator systems, but I don't think they had a robotic arm on it. So these are antennas or cameras, but not necessarily a robotic system. Now, this is the one you know about, Tim Peake. And he was launched into space in December of 2015. He spent 85 days in space. So this is Tim with the other, this might be Tom instead of Tim Copra. And they're celebrating, they're sharing a card of 100 days in space. And he ended up staying in space for 185 days. They're smiling and having fun. So in the end, when I was young, I didn't think I'd work for NASA. I ended up working for NASA, then having the opportunity to develop displays for the astronauts to use. Therefore, I ended up knowing astronauts because I did crew evaluations. And then because I worked on robots, those are easy to showcase. So I've done demonstrations for various people, heads of NASA, the heads of ESA, the Queen and things like that. So I've had a work career that I never expected to have when I was 10 years old. So now it's time for questions.
Thank you so much, Sue. Really, really appreciate that. And I've learned so much myself. So I just want you guys to do something. Before we start taking questions, I've written down a whole lot of questions of people who had asked questions on the chat. But before we do that, I just want you to type in the chat one word that you found this presentation. If it's fantastic, if it's phenomenal, if it's anything, just type in the chat. However, one word. Insightful. Keep coming. Just one word. Factual. Interesting. Interesting. Amazing. Enlightening. Super. Inspirational. Inspiring. Amazing. Thank you guys so much. And Sue, I mean, this has really, really been mind-blowing. Someone said mind-blowing. I think it's been mind-blowing for me as well, because I've learned so many things. I've learned about the Canada Arm. I've learned about space stations. I've learned about different things. So I'm just going to take a few questions. We wrote down a few questions that some people asked. Grace Campbell, we have about five questions, and I'm going to start with the first one. Grace Campbell said, how many tests and studies do you have to do to get into NASA?
To become an employee? No,
Yeah.
you don't have, you submit a application and then you have a job interview and get selected as an employee. Now, to do an astronaut, to become an astronaut, there's a lot more rigor there, and you have to do studies. Oh, but studies of courses.
Courses, I think that's what she meant.
Yeah, now that I think of them. So there's various fields at NASA, like there's medical doctors that work at NASA, but then there's people that can write very well in the technical area. So various degrees. There's accounting people that do the budgetary work. There's people that do public affairs that are interested in, you know, doing the YouTube videos, doing the press releases. But the majority, or a significant majority of the people, are science degrees, engineering, physicists, biologists, and that's usually your degree of study when you go to college. When your age is between 10 and 16, you know, try to take some of those science classes, those math classes that are mandatory, you know, emphasize that and try to excel in those. And if you need help, get either your parents or mentors or tutors to help you. And so that's my answer.
Thank you, Sue. The next question was from Kachimsi, and Kachimsi said, what age would you be able to go into space school?
Space school. Okay. So I know that there's there's different answers to that question. There's space schools, space camps in the United States. I know there's one in Greater Houston. It's on.
Wait, can I ask this one question? Why are we doing this on Microsoft Teams?
Can you leave that question till later, please? We'll get back to that. Let her just finish, okay?
So there's camps that you can go to, like in the summertime. And I know there's one in Greater Houston, Texas, and one in Huntsville, Alabama. And I think you have to be about 10 and on up in age. And I know I actually took my daughter and another friend and we did this. You know, my daughter's now a mother herself, and we camped there on a weekend, and we built a robot, and then we did a fun little thing of traversing the robot through a brick path. Clapping was the way it moved. We came in second place in operating it.
Wow.
But if you're talking about becoming an astronaut, usually that's done after you've gotten your college degree and apply there.
Okay.
Thank you very much. The next question was from Muna. And Muna said, why are robots flown into space to examine planets and moons?
Because we want to discover things. We like to be explorers. There were explorers long time ago that explored the countries and went from beach areas to forest areas. When we humans tend to want to know things, so we're exploring the planets, and there's curiosity if there's life on other planets, and that life we don't think is human, but maybe at the biological level, low level, there might have been some things. And then we want to see what we can learn from the other planets to help us here.
Okay, yeah, thought so too. Thank you. The next question was from Deborah, and she said, does NASA own up to half of the robots in the whole world?
No. There are now lots and lots of robots. And there's all the rovers that the Jet Propulsion Laboratory of NASA builds to go to Mars, and then the rovers that were on the moon. But there's Amazon's got robots that are stocking shelves there. So those are lots of robots and delivery systems that NASA is not involved in. Commercial enterprise is, but that's the neat part.
Okay. Thank you. I know time is fast spent, and I'm very conscious of that, but we'll be taking 3 more questions, which I will take quickly. The very first one, the next one is, how long do space shuttles stay in space?
So the space shuttles stayed about 10 days.
10 days.
They could stay 5 days, but the space shuttle didn't stay in space very long.
Okay.
But space station has had a man or woman on it for 20 years this year. So
wow.
Piece parts were put together without man, and then when they got the living quarters, they've been living there for over 20 years.
I was just about to ask a question, but I won't use my question to replace another person's question. But the next question was, how did NASA start?
So it started as a scientific...
Oh, I know one.
I think it started as a science and technology driven community or collective effort, and it was for aviation, and then ultimately to go to space.
Okay, that's cool. The next question was, how do you make rockets? It's a bit of a broad question, but in a short answer, how do you make rockets?
So you manufacture rockets, turning metal, and then you have to have propellant, and sometimes there's liquid propellant, and then sometimes there's solid propellant. And when I say propellant, that's fuel that you ignite to cause energy to make it move. And then there's engines that can be maneuvered to help steer it.
Okay, that was very concise and very good. Thank you, Sue. The very last question, which I'll be taking, is from Komet, and he says, does the Earth have many metals that come from space?
So I'm not a geologist, and but there's a lot of common metals and common geological items on Earth and the moon. I think in the end, geologists were underwhelmed. They were surprised that the moon, when we landed on the moon when I was a young child, they brought back rocks and dirt and samples, and they weren't of a significant variety. Kind of disappointing.
Okay, thank you. I think we have a geologist on the call. He said, yeah, it does from meteors. Okay, so thank you so much, Sue, and thank you to all of you who have dialed in. We had people from India, from Finland, from Aberdeen, Scotland, from Yorkshire, from Nigeria, from Texas, Southampton, UK. I want to say on behalf of all of us, a big thank you to Sue for taking time out, because I know it's quite early there, to give a talk to us. And if you can drop in the chat, just let Sue know how much you enjoyed it. And from all of us at NextGen, we say thank you so much. Just to keep you updated with our programs, we will be having programs every month, twice in the month, depending on how many weeks there are in the month, but bi-weekly. And we will be sending out emails to you. So make sure you register, make sure you tell your friends, make sure you tell your neighbors, people in your school, just to log in, and we'll keep you updated via emails. Okay, so thank you so much. Thank you, Susan. Learned a lot. And thank you to everyone who dialed in.
And I'll answer the young gentleman's question why we use Teams today.
Okay, yes.
We use Teams today because NASA does not allow me to use Zoom. And then there's another program called WebEx and Skype. But
why?
we use
is it illegal to you?
We cannot use Zoom on and I'm using my NASA computer today. And there was security issues, so NASA hasn't chosen to buy that program.
Thank you, Sue. Really appreciate it. If you can now unmute your mics just before you leave the meeting, just say a big thank you to Sue, and we will see you next month.
Thank you.
Thank you. Bye.
Bye.
Thank you. Bye.
See you.
Bye.
Bye. I had fun.
Thank you.
Bye.